No other city in Western Canada faces more windy days in a given year than the city of Lethbridge. Winds here can achieve speeds of over 120 kilometers an hour, and as a result, the city has been grappled with some very serious environmental and organizational hazards during the recycling collecting process. On any given day, residences can expect to have their recycling bins tipped over and even blown away by these very high velocity winds. Not only does this prove as a huge inconvenience to the community, but this common spillage of the contents within these bins leads to severe environmental concerns, as many of today's common recyclables are very damaging to the local ecosystems.
In light of this situation, we have designed a series of easily applied mechanisms that will be sure to resolve this standing issue. It allows the containers to be as stationary as possible, as well as keep the contents within them secure, even in the most fierce and unpredictable weather conditions. Based on our understanding of the city's frustrations, it was important to us that we created a solution that struck a balance between ease of use, cost-effectiveness, and sustainability. It also satisfies a multitude of other potential variables, including other unpredictable weather conditions and ensuring compatibility with the side-loading collection process.
Knowing the sizable nature of this issue, we decided a multifaceted approach would be required. Through our collaboration, we investigated every possible solution, including features such as a ground-mounted rail system, curved attachments to deflect wind, hand-activated suction cups, magnets, and more. During this exploration, we designed and prototyped many devices which ultimately did not make our final project. These included side and triangular support bases, complex mechanical parts containing springs and more which posed the potential to interfere with the collection process, multiple designs for wheel locks, and many iterations of our gravity lock were exchanged for a more effective and simplistic approach.
We present our three-stage solution that focuses on ease of installation for the end user while ensuring that absolutely nothing interferes during the collection process. The counterweight serves as our first line of defense. We needed a design which would appreciably lower the bin's center of mass while still being easy to install by anyone and keeping bin mobility at a maximum. The rubber counterweight is cut for a friction fit at the bottom of the bin with relief cuts on the sides for an easy insert. Just shy of 12 kilograms, it has been calculated through simulations to increase the force required to tip an empty bin by a factor of 2. When caught by the wind in just the right way, the entire bin tends to act like a sail, remaining upright and rolling away down the street. To help prevent this, a pair of wheel locks are used to stop rotation when engaged. These locks have been engineered for both a minimum part count and for the simplest user experience. When the main rod is inserted through the wheel, a silicone seal keeps it tightly in place, but when the user wants to move their bin, they simply pull the seal free and an attached chain ensures the rod never leaves its bracket. The materials have been carefully selected to accommodate the large range of temperatures found over a Canadian year. The gravity lock is engineered so that it only opens at the height of the bin being lifted for collection. A chain connects the pin to the lock, keeping everything together. When installed, the gravity lock safeguards the beauty of Lethbridge from the environmental hazards of loose waste.
As mentioned, it was important to us that our solution was cost-effective. The kit contains no complex parts, reducing the production costs and requiring only a drill to easily set the entire assembly up. We wanted to make sure it was sustainable, easy to install and replace components. Our plan includes the possibility of having the counterweights made from recycled rubber tires, making new use out of old ones, and repurposing almost 400 tons of rubber waste for years to come.
Finally, it's reliable. In simulations, our solution appears to be 2 times more effective in preventing unloaded bins from tipping over, even under extreme forces, for example, 120 km/h winds. We're confident that our unique, sustainable, and cost-effective approach provides the gateway to opportunity that is Lethbridge, with more opportunities for success in the future.